guys, welcome back to the channel again. Let's solve another challenge. Today's problem is from number 994, rotting oranges. This is a very interesting problem. This will be in the line of our previous solved problems where we tried to compute the distance between the rooms to the nearest gate, right? So let's see what the problem is really asking. So we are given m by n grid where each cell have one of three values. 0, it represents empty cell. 1 representing a fresh orange, that's where the fresh orange, and 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Whatever orange is touching that rotten orange, that will be rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, we need to return -1, which means we could not rotten all of the oranges, right? So this is an example. We will look at more in the whiteboard. So let's look at the constraints. So we are given just a grid, so we can compute the length of the grid. We can compute the number of rows and number of columns. And this is a pretty small grid, but we need to write an efficient algorithm so that it should be able to handle much larger grid too. So in this example, in this problem, our grid size is it can range from 1 to 10, and each grid value I and j, it can have 0, 1, and 2. So let's understand the problem statement clearly in the whiteboard. So as I said, this problem is very similar to approach that we use to solve the problem walls and gates from a LeetCode 286. So I have the video in this graph playlist. I highly recommend you go through that problem to see the connection between this problem and the other problem, right? So let's understand the problem. So in the example 1, all of the rotten oranges, we are given this grid. All of the rotten oranges, we have number 2, because we cannot pass the oranges rotten in picture, right? Computer cannot recognize those images when we just pass. So the grid empty cells, they are 0, so there is nothing. And all of the fresh oranges, we can just add 1. These are all fresh oranges, right? These are all fresh oranges. So now we need to return the problem that we are being asked. We need to return the minimum time that takes to make all of the fresh oranges rotten. Let's say if in this first example we are given this in the 00 cell, in the cell the orange is rotten, and we need to look at whatever orange is touching that specific orange in the 4 directional way. Let's say this one, right? And this one. This 2 orange in elapsed time in 1 minute, in the next 1 minute, this 2 orange will be rotten. This 2 orange will be rotten initially, then we increment this one to 1 elapsed time, right? Now this is the direction. This goes up, this goes down, this goes right, and this is left, right? So from each cell, we can go only to 4 direction. From this 00 cell, we cannot go to up because that is the boundary. We cannot go to the left, that's also a boundary. So we can go to only right and down, right? And we can make this, we can mark this 2 oranges rotten. So we increment the time, right? And after we reach here, we add initially we see which oranges are touching this. Either we can make this orange rotten due to this one, or we can make the rotten due to this one. This orange is basically touching both of them, right? So in the next minute, this orange will definitely be rotten because of this, and this will be rotten because it's touching 2 cells, right? Then we can increment the time. So basically it's a second minute, right? In the third minute, this orange is touching this rotten orange, right? And in the third minute, this will be rotten. So we increment time to 3. Then finally, this orange will be rotten. So this will take 4 minutes, right? So we can analyze this by layer by layer. What I mean with the layer by layer, so initially we can say that this layer is rotten. In the second minute, this is layer 1, I say, and then second minute, this layer will be rotten, right? This is the second minute. In third minute, there is only 1. In fourth minute, we have the last one, right? So basically, initially, this is the first layer. That's already rotten. So that's the time 0, and the time 1, time 2, time 3, and time 4. Basically, it takes 4 minutes. So is this always the case? Can we rotten all of the oranges during our process? Let's see another example. So that will make the things much clearer, okay? This example too. Let's say, the problem, we can have multiple rotten oranges in the grid, or we can have just one orange, right? So let's say first this middle orange is rotten. If we can really make all the oranges rotten, right? From here, in the next 1 minute, how many oranges we can rotten? We can go this right, we can go to the up, we can go down, we can go here, right? And these guys are already empty cell. There is no orange, so we cannot do anything here, right? So all we can do, this will be rotten, right? That's elapsed time. So it takes for this layer, it takes, let's say, for this layer, it takes 1 minute, right? So the next one, from here, we can make this one rotten, right? And we can make this one rotten, right? Because we can go up, left, up, down, the right and left. Only down has the orange, so we can make this one rotten. So this is a 1 minute, and this guy, these two guys will have this, let's say, 2 minutes, right? Then from here, I can go this way. It takes, I can make this one rotten. That will be, last time will be 3 minutes, right? I have 2 more oranges, which is I can label in blue here, this 2 top and bottom, top right and bottom left corner. There are 2 oranges. I cannot really make them rotten, right? So they are not being touched by the rotten oranges because we cannot go diagonal. We can only go left, up and down, left and right? So if we just see all of these, then initially we need to check how many fresh oranges we had, right? How many fresh oranges we had. The number of fresh oranges, right? Number of fresh oranges here is 1, 2, 3, 4, 5, 6, 7, right? So initially the number of fresh, how many we counted? 1, 2, 3, 4, 5, 6, 7. Number of fresh oranges, 7. So after certain time passes, we can make this one rotten, these two guys, and this, and this, and this. So total number of oranges that we can rotten, we don't count this one because initially it was rotten. Then that is 5. So we need to check if number of oranges that we can rotten after time is equal to 3 minutes, if these are equal. Because initially we had like 7 fresh oranges. At the end we can return the number of rotten oranges to be only 5, right? And they are not equal, right? In that case, we need to return -1, which means like we could not rotten all of the oranges, right? So how are we going to approach this problem? I hope the problem statement is clear. So again, it's going to be, as I said, it's going to be multi-source BFS. What I mean with multi-source, this orange, the number of rotten oranges, right? It can be just one orange rotten. It can be multiple orange rotten, right? So we need to add these oranges to the queue, right? To the queue. So this one will be to the queue 1, 1. And this one will be 2, 3, right? 2, 3. So this will be the first layer. The time will be 0. Then in the next iteration, we pop one of them. Let's say 1, 1. This one, right? We pop this one, and we go all 4 direction, right? We go all 4 direction, and see if we can add any oranges, right? This one in the next queue, after we pop this one, then we will be adding to the queue 0, 1, right? 0, 1, and 1, 2. And this and this will be added to queue 0, 1, and 1, 2, right? We need to add this one and this one to the queue. Then we pop also this one. After we pop this one, and we can count, we can mark this one as rotten. We can add this one to the queue, which will be 2, 2, right? So then we add 2, 2 to the queue. After all of this, then what's in the first queue, right? Now we are done the first layer of marking all of the in the first layer. This in the 1 minute, right? In 1 minute, this will be rotten, and in the next minute we can only rotten this one, right? In the second minute, right? We can pop this one and add this one to the queue, right? That will be 0, 0, right? That 0, 0 will be added to the queue. Then we can see this will be, and these two guys we cannot rotten. During this time, initially number of fresh oranges 7. After we rotten each one of these, let's say 1, 2, 3. After we mark them as rotten, we just keep decrementing this one by 1, right? Because after we rotten this one, let's say this, and we decrement this to 6. After we rotten this one, we decrement this to 5, right? After we decrement this will be 4. Then after we rotten this one, then we decrement to 3, right? And initial number of because this is 6, right? 6 and 5, 4, 3 and 2. Because we have right now 2 sources to be rotten, right? So we have here 2 more oranges left. So we at the very end of the code, after we process this multi-source BFS with Q, we check if the fresh oranges, if it's equal to 0, right? Right now, apparently it's not 0 because we have 2 oranges left here. 2 oranges because the 2 oranges still fresh. So in this case, we need to return -1. So in this case, for example, in the first case, number of fresh oranges, because we had only the first one, 1, 2, 3, 4, 5, 6, right? The fresh, it was 6. In the first iteration, 1, 2, we need to decrement this by 2, which will be 4, right? And the second iteration, this will be, again, 2 of them will be gone, so 2. In the next iteration, only 1, so it will be 1. And the final one, it will be 0. So in this case, we need to return true. In this case, in this case, we need to return the number of how long it took to rotten all of the oranges. Let's say at the end we ended up with 0 orange because everything was rotten. In the second example, we ended up with 2, which means that we have 2 oranges left that we could not really rotten. Yeah, I hope this explanation is clear, and please share your comments. And I highly recommend that this problem is clearly related to the walls and gates, and the time complexity of this is basically O m times n, which means the m is the number of rows, n is the number of columns, because we are going through this 2 times, right? In the first one, we are trying to collect all of the rotten oranges and trying to count the number of fresh oranges, right? That's what we're going to count. And in the second iteration, we are just trying to just go until the queue is empty. And that's this time and space is going to be O m times n. Okay, so these are the time and space complexities. Now we are going to go and see the code. Okay, yeah, this is the code. Initially, we will check if the grid is, if not a grid, then we just return because there is nothing to process. Then these are the values that we define, and the problem is given, right? Empty cells, it's 0 in the grid, and the fresh oranges is 1, and rotten oranges, they are 2. Then we compute this. Rows and the total rows and total columns of the grid. Then we define the directions, right? What are the directions? And this one goes to up and down, and this one right, and this one is left, right? Then initially, in the first iteration, when we traverse the grid, we need to count the total fresh oranges, and we need to initialize the double-ended queue to add all of the rotten oranges to the queue to process, right? So for the rows and for the columns, we check if the grid at the specific row and column is fresh. Fresh is 1, right? If it's equal to 1, then we increment the total number of fresh oranges, right? And if the row and column of the specific cell is rotten, then we add the rotten cell, row and column to the queue, right, to process the time, right? So here it's interesting if the total number of fresh oranges is 0, so we need to return 0 because it means like all the oranges are rotten, right? It doesn't take any time to return that. Okay, this is everything is here, rotten. If the total number of fresh oranges, this is the initial check. If the total number of fresh oranges is non-zero, and the length of the queue is 0, which means there is no rotten oranges, right, in the grid. Which means that in that case we need to return 0, -1. That's when means like all of the rotten fresh oranges, we cannot rot them because there is no rotten orange in the grid, right? Then we initialize the time to see how long it takes. Then we perform this multi-source BFS. It's just a typical BFS algorithm. While queue is not empty, we get the length, the size of the queue. Then that size of the queue basically tells which layer. Once we are done with all of this for loop, which means that we are going from each item in the queue. We pop the queue. We get this queue. Please note that this queue has only the rotten oranges at the very beginning, right? Then later in this loop, we add the neighbors of the rotten oranges after we mark them as rotten, right? Let's say we pop a specific row and column. Then from that cell, we check for direction, right? That we compute the new row and new column, row plus dx, row plus dy, and this direction we defined in the very, very top here, right? So row and column, after new row and new column, we check that, we cannot go out of bound of the grid, right? So new row if it's between 0 and the rows, and new column is between 0 and columns. If the grid is fresh, we only process the fresh oranges, right? We don't process the rotten or empty cells. Empty cells means nothing in there, right? So if then after it's fresh, then we mark them as rotten, right? That's what we do, right? Because that fresh orange is touching the rotten orange, so we need to mark that as rotten. Then we need to add that rotten orange coordinates, row and column, that specific cell where the rotten orange is. After we mark them, then we add them to the queue, and then we decrement that total number of fresh oranges by 1, right? We need to decrement this, right? Because that orange, it touched the rotten orange, fresh orange, right? That fresh orange touched the rotten orange, so now it became rotten. So total number of fresh oranges we need to decrement. If that queue is still non-empty, then we increase the time, right? So this basically goes through each cell in the grid, right? And whatever is neighbor to the rotten orange. And at the very end, we need to return time if total number of fresh oranges are 0. If total number of fresh oranges are not 0, like in our second example, we ended up be like still 2 fresh oranges, right? So in that case, we need to return -1, right? So this is, as I said, this is very similar to the problem walls and gates. So to see how much time it takes for all the fresh oranges to make them rotten after they come into contact with a rotten orange. Otherwise, we need to return -1, right? So yeah, that's it for this problem. I hope you guys liking this explanation with the whiteboard and the problem, the code walkthrough. And please share your comments and likes and share this problem and solution with anyone you think might help. Yeah, thank you. See you in the next problem.